this video, what we're going to do is we're going to talk about the notion of biconditionals. We're going to talk about the rules of biconditional elimination and biconditional construction, that is double arrow out and double arrow in. Things that we can do with biconditionals, statements that mean biconditional, like if and only if, just in case, exactly if, and we're going to get it into some preparation for quiz 5 as well. All right, let's start talking about biconditionals. So biconditionals, we've talked about conditionals, we've talked about conjunctions, we've talked about negations. What are biconditionals? These are if and only if statements, which are represented by the double arrow. So let's go ahead and talk about some of these and what we do with them. I actually think biconditionals are easier to deal with than negations, but let's see what we've got. Biconditionals are represented by the statement if and only if. So here's what a biconditional looks like. A double arrow B. So when we see a biconditional, we can represent it by the phrase if and only if. That's one of them. We can represent it by the phrase necessary and sufficient condition. Conversely, we can represent it by saying sufficient and necessary condition. Both of these kind of give a hint as to what it means. And then two other weird phrases that don't pop up in English very often, but we're going to use them anyway. Just in case. And then also exactly if. If we're going to get real British, we can say precisely if. I'll put that one there too, just in case. See, I just said just in case to demonstrate precisely if. So all of these, if I had A double arrow B, it's the same thing as saying A if and only if B. It's the same thing as saying A is a necessary and sufficient condition for B. It's the same thing as saying A is a sufficient and necessary condition for B. It's the same thing as saying A just in case B, A exactly if B, and A precisely if B. And also, I'm going to go ahead and say here vice versa. The way the double arrow works, it's basically saying that the arrow works in both directions. What you're saying here is this is a well-formed formula that's saying the shorthand, and so I'm going to say we can say it's the same thing as saying A leads to B and B leads to A. In other words, the arrows lead into each other. Hence, you remember I said, whatever follows if, remember, goes on the left side of the arrow, but then I said if you see only if, draw an arrow right over it. Well, what's going on here is it's saying the arrow goes in both directions. One thing leads to the other. Let's take a look at what I mean by this. And so these are all the phrases that we could use to represent the double arrow. And the double arrow means that, hey, A is leading to B and B is leading to A, which means A double arrow B is actually the same thing as saying B double arrow A. The order doesn't matter. One thing's leading to the other. That's all. And vice versa. That's what it means. So let's take a look at that. All right, to explain the notion of a biconditional, a double arrow, I'm going to take two statements here. I'm going to call this one S1, I'm going to call this one S2. And one of these is true and the other is false. That is, one of them works and the other doesn't. So let's see. A shape is a triangle if we see IFF like this. That's another way of saying if and only if. It's a necessary and sufficient condition. It's a sufficient and necessary condition, just in case, precisely if, exactly if. It means the same thing. Okay, it's another stand-in for the double arrow. So this says here, a shape is a triangle if and only if it has three sides. What does that mean? Well, T, and then the if means double arrow, S. This means if a shape is a triangle, it has three sides, and if a shape has three sides, then it's a triangle. Is that true? Yeah, it is. Okay, let's take a look at this one, though. So this is true. This checks out. The double arrow here is legitimate. Let's take a look at this one. A shape is a square if and only if it has, and I'm going to say 4 here, so we'll do F for 4. If and only if it has 4 sides. So let's take a look at this one. This one would say, I'm going to go ahead and say it's false, but this one would say you got a square if and only if you have 4 sides. Here's the problem. If you've got a square, does it have 4 sides? Does that check out? Yeah, that one does. If you've got a shape that has 4 sides, is it a square? No, that does not check out because you could have a rectangle, you could have a diamond, you could have a quadrilateral of some kind. So this does not work this way. So this is not an if and only if statement, like in reality. It doesn't work. So if and only if works if it means the same thing both ways. So if something's a triangle, it has three sides. If it has three sides, it's a triangle. If it works both ways, you can say, hey, it's a triangle if and only if it has three sides, which is the same thing as saying it's got three sides if and only if it's a triangle. You can say it either way. This does not work. It doesn't work in both directions. This works one way. All right, so that's why I said this one does not work. If a shape is a square, then yeah, it totally has four sides. But if a shape has four sides, then it might be a square. So the fact that it might be something else, it might be a diamond, it might be a rectangle, it might be a quadrilateral. For example, it might be a trapezoid. It doesn't work this way, so it's not an if and only if statement. So if and only if statements or double arrows are kind of ways of stating definitions. You're saying this thing leads to this thing, and this thing leads to this other thing. Back and forth. Think about back what I said on quiz 1. I said an argument is valid if and only if. It's a double arrow. The premises are true. Sorry, an argument is valid if and only if the premises are true, and I'm going to abbreviate T for true, then it's impossible for the conclusion to be false. Oops. It's impossible for the conclusion to be false. What does this mean? Well, since it's a double arrow, what it's saying is here, this definition works in both directions. If an argument is valid, then if the premises are true, then it's impossible for the conclusion to be false. It means that, and if the premises are true, then it's impossible for the conclusion to be false, then the argument is valid. What it's saying here, the argument works in both directions. That's what a double arrow is and means. Again, it's shorthand for saying this. If you got this, and you got this, the arrow goes in both directions. That's the same thing as saying A if and only if B. It's the same thing as saying also B only if A. It works in both directions. That's precisely what the double arrow means. And so that leads me to two rules that we can use with double arrows, with biconditionals. Let's get into it. This means that for double arrows, there are just two rules that we're going to deal with. Okay? The first one that I'll talk about is the notion of double arrow out. Okay? Double arrow out. And so what this one says is if you have a double arrow, so let's say we got this, A double arrow B as an assumption, that breaks down into saying the following two things. If A leads to B and B leads to A. So in other words, A double arrow B is the same thing as saying if A then B and if B then A. And that would be double arrow out on line 1 for both. It's saying, the double arrow is saying this leads to this and this leads to this at the same time. So again, a double arrow is just a shorthand version of saying this. A leads to B and B leads to A. But the well-formed version of saying this would be this right here. So this is one rule we've got, double arrow out. If you got a double arrow, it breaks down into the arrow going in both directions. That also leads us into the next rule, double arrow in. Double arrow in is the exact same rule, just in reverse. If I have this, if I have A arrow B as an assumption, and I have B arrow A as an assumption, that means I can get A double arrow B. How? Double arrow in lines 1 and 2. But also, not only this, in an alternate version, if I needed to, I could the direction in the double arrow really doesn't matter. So I could also get, if I needed to, B double arrow A with the exact same reasoning. I'm going to switch it up a bit. I'm going to say 2, 1, because if the B came first, I'm going to follow 2's lead. So this is double arrow in. If I have an arrow and I can see like A leads to B, B leads to A, that's the same thing as saying A double arrow B. It's also the same thing as saying B double arrow A. So I'm going to put which one of these I need to. I'm going to build which one I need to depending on the situation. Let's take a look at a couple of examples of that. Alright, let's take a look at an example of a sample problem with double arrows in it. So this says, Madeline moves to Columbia if and only if she does graduate work. What would that be? Line 1. Okay, she moves to Columbia if and only if, so double arrow, she does graduate work. Assumption number 1. And then it says, so, which means, here's what we're solving for. So, prove this. She does graduate work if and only if she moves to Columbia. And that would be moves. And so, in a certain sense, these are logically equivalent insofar as just like A dot B and B dot A are equivalent. But just like there, we need to say how we get from one to the other. We have to do the same thing here. And it's not with and outs, it's with double arrow outs and ins. So let's see if we can do it. So here's what we do in this situation. With double arrow out, all right, if you got a double arrow, what that means is you can turn it into an arrow going one way, and the arrow going in the opposite direction. And then double arrow in is if you have an arrow where you've got like something like this, like A arrow B, and you've got B arrow A. You can put those together. That's what we're going to work with. We're going to work with these two and see what we can do in this problem. In fact, this problem will only require this. So let's see. Here's what we do in this scenario. Do we have a double arrow? Yes. If you got a double arrow, go ahead and get it out. So one of the arrows is going to be the exact same thing, but instead of a double arrow, you've just got a plain arrow. That's double arrow out on line 1. And then you're going to get the exact same thing going the other way. So we also get G arrow M. That's also double arrow out on line 1. So what this is saying is, Madeline moves to Columbia if and only if she does graduate work. It's the same thing as saying, if she moves, then she's doing graduate work. But also this other thing, if she's doing graduate work, then she's moving. We did that from double arrow out. But double arrow in also says, if you got two things going, like this thing leads to this, and the other thing leads to this, so look at this. This is the sufficient condition, so M here is the sufficient condition for G, but also G is the sufficient condition for M. That means M is a sufficient condition for G, and it's also a necessary condition for G. That's why we can also say double arrows means something is a sufficient and necessary condition. I could also say, G is a sufficient and necessary condition for M. So that's why we can get the double arrow. So what we're doing here, the goal is, say, G double arrow M. Well, this just means we can recombine these things in a new manner. We can say, look, G double arrow M, double arrow in, where do we get those pieces? 2 and 3. We could also say 3 and 2. In fact, I would probably do that just to follow the lead of whatever letter's in play, but it's right the other way too. So here we go. That's how we do a problem like this. Okay, let's take a look at this argument. The government may restrain the publication of news if and only if it may compel the publication of news. What would that be? As it's given, and again, you have with double arrows, you have the option of putting it in either direction. Do it in the way that it comes. So I'm going to say here, line 1, R double arrow C. That's what we got. It may restrain if and only if it may compel. Okay, line 2, the government may, notice here we got a not, may not restrain the publication. Okay, so the government may not restrain publication. Assumption number 2. It clearly follows that it is also not permitted to compel the publication of news. Okay, let's do it. And here's what we have in play now. This is what I want to stress. We've got, first of all, can we do an arrow out? Can we do a modus tollens? And now this is new. Can we do a double arrow out? Can we do a double arrow in? And then the stuff that we did before. Okay, can we do an and out? And then, can we do an and in? Can we do a double negation? And then emergency case scenario, can we do an arrow in or an indirect proof? Okay, so here, do we have an arrow not in parentheses? No. So we can't do arrow out or modus tollens. So I'm going to say right now, don't mix up arrows and double arrows. Don't do it. Okay. So, no, no. Do I have a double arrow not in parentheses? Yes, I do. So what should I do now? Break that down. That gets you two things. You get R arrow C, and you also get C arrow R. Both of those are double arrow out on line 1. Okay. Now, can you do an arrow out? Okay, do we have arrows not in parentheses? Yeah, we got two new ones. This one and this one. Left side matches? No. Do we have any right side contraries? Yes. Look, we have a contrary between line 4 here, C arrow R, and look, its right side is R, its contrary is squiggle R. So that means we get squiggle C. How so? Modus tollens, 4 and 2. Great. All right, let's take a look at this problem here. We got D arrow E, and we have separately E arrow D, and we want to get D double arrow E and E double arrow D. This one's ridiculously easy, but doesn't look like it from first glance. So first of all, can we do any arrow outs? We got two arrows not in parentheses, arrow outs, DE, left side matches. Right side contraries, squiggle E, squiggle D, no. Can we do a double arrow out? No. Can we do a double arrow in? Yeah. In fact, we can do two. And look, what we're going for, now the last move in this problem, we're going for an and this has been true for a while. If you're trying to get a dot, the last move is going to be an and in. And 100% guaranteed, the last move in this problem is going to be an and in. But if you're trying to get double arrows as well, odds are you're probably going to do a double arrow in. So look at this, D double arrow E. Do we have the pieces to build it? Actually, yeah, look, if D leads to E and E leads to D, that means that's the same thing as saying D double arrow E. How so? Double arrow in, line 1 and 2. Now look at this, that's one of them. The other one is the exact same thing, just switched around. Do I have the pieces to build it? Actually, yeah. I can get E, double arrow, D. How? Double arrow in, and I'm going to say here 2 and 1, just to follow the lead of the E. But it's the same thing. I could use the same numbers to be fine. So look, I have the two pieces. These are the two things that I need. What do I need to do? Just add them in. D double arrow E and E double arrow D. How to get it? And in 3 and 4. Problem is done. Let's take a look at just one more before we get into the problems from the book. All right, let's take a look at one more example before we get into the problems from the book. So this one, we got this. A, double arrow B, A. So your immediate visceral response might be, oh, I've got a left side match. That leads me to B. Bam, I'm done. There's a way to do that later on with another move. But based on the moves we know, this is not a left side match because that's not an arrow. This is a double arrow. So do we have an arrow not in parentheses? No. So we can't do an arrow out modus tollens. So we have a double arrow not in parentheses. Yeah. So what does that do? That breaks down into two things, A arrow B and also B arrow A. Okay, so here was our first assumption. This was double arrow out on line 1, and this was also double arrow out on line 1. Okay, now I've got two sets of arrows. Okay, the line 4 I actually don't need. Do I have a left side match now? Yeah, between 3 and 2. What does that get me? B, which is what I was after. How did I get it? Arrow out. Not between 1 and 2, but between 3 and 2, because the arrow out, use the arrow here. You can't use arrow outs on double arrows. Okay, so this problem is done. Now let's move in to some of the problems from the book. All right, now let's get into a couple of problems from the book. And specifically, I'm looking at the problems from pages 86 all the way to, we'll make it up to number 15 on page 90, so 86 through 90. Let's start with number 1. So number 1 here, that's one of these translation ones. So we've got A, B, C, D, and E. Let's start with those. Do those 5, and then I'll do a couple of these other ones. Some of these are more challenging than others, and like I said, towards the end of this video, or at the end of this video, I'm going to go over some ones that you'll actually have on quiz 5. So actually, let me go ahead and throw F. I got room for F as well. So let's take a look at these. Right. Number 1 says this. This is on page 86. Our justice system works if and only if witnesses are willing to come forward. So I'll say this, kind of like, remember I said if you see the words only if, what you should do is draw an arrow right through it. Well, I'm going to say here, if you see, on the other hand, if and only if, or any of its equivalents, draw a double arrow right over it and you won't mess it up. Okay, so keep that in mind. So right here, what I saw in here was this. It said J, basically, if and only if, that means double arrow, F. Yeah. Our justice system works if and only if witnesses are willing to come forward. Now what this means is, if our justice system works, then witnesses are willing to come forward, and if witnesses are willing to come forward, then the justice system works. Okay, that's what this would mean. Let's take a look at B. If and only if, oh no, it starts with if and only if. Well, that means go ahead and just write the double arrow down. Okay, whatever follows it really can go on either side, but I'm going to do it as it comes. If and only if it is a motion on racial research is approved by a majority of the AAA membership, will it become the official position of the American Anthropological Association? So if and only if this, what was left? This. All right, let's look at 1C here. We've got let's look at 1C here. I'll let you pay for the meal, just in case. What does that mean? That's another way of saying if and only if. As soon as you see it, just make a double arrow. I'll let you pay for the meal, just in case you allow me to leave the tip. What does that mean? If you're paying for the meal, then I'm paying for the tip, and if I'm paying for the tip, you're paying for the meal. Okay. Again, any of these double arrows, you could actually write it the other way. This is just as correct for number 1. This is just as correct for number 2. This is just as correct for number 3. Because double arrows doesn't matter what order they come in. Okay, D. I will read Grimm's logic qualifier, but only if the first 2 readers disagree. Or A would stand for the first 2 readers agree. I don't really like that. So here's what's going on here. Only if. Well, there's an only if there. Is that an arrow or a double arrow? That's not if and only if. That's an arrow. That's just plain only if. That's an arrow. So what I'm going to do is I'm going to write it exactly like it is. It says, I will read Grimm's logic only if. That button there means nothing. It's just there. But only if, so what? Only if, just draw an arrow right over it. Only if what? The first 2 readers disagree. Now, A would stand for they agree. So he wants them to disagree. Let's squiggle A. All right, now let's take a look at E. E says, these 2 statements are equivalent if and only if each entails the other. Okay, so we've got their equivalent. If and only if there's a double arrow, each one entails the other. So A stands for S2 entails S4. B stands for S4 entails S2. How am I going to write that? Well, they're equivalent if and only if this thing's true. S2 entails S4, and S4 entails S2. Bam, there it is. Let's take a look at F now. We got this. The assistantship will be offered to McGraw if and only if he does not get a tuition waiver. Stop, because there's a semicolon there. How many things to the left of that semicolon? 2, so I know they're going to be in parentheses. Okay, let's go back and just fill it in. The assistantship will be offered to McGraw if and only if. That means M, if and only if, is a double arrow. If what? He does not get a tuition waiver. After that semicolon, it says and, which means what's coming after that parentheses is a dot. And then it says it will be offered to Spiegelman if not offered to McGraw. So, just revealed what's on the right side of this arrow, or the right side of this dot, is an arrow. Because I saw that if not offered to McGraw. So it goes on the left side of this arrow, not offered to McGraw, then it goes to Spiegelman. So here's what this is saying. If McGraw's got it, then he doesn't have a tuition waiver. And if he doesn't have a tuition waiver, then McGraw's got it. But also, if it's not offered to McGraw, then it's going to be offered to Spiegelman. Okay, that's A through F. Let's take a look at G, H, and I. All right, now let's take a look at G, H, and I. I don't like any of these. I'm not going to give you ones like these, I don't think, because they're not very straightforward. And so, in fact, I think the author of your textbook is trying to trick you here on some of these. But let's work through them anyway, in case we do encounter a problem like this not just on a quiz, but say in the real world too. So G, Greta's father will donate the kidney she needs. And it uses this word expression, but not unless he's here. That is in the United States. So that presents us with the following scenario, and this is one of those if you think through it, it makes sense, but it's not obvious looking at it, or it's not as obvious as it should be. So I'm going to read that back one more time. Greta's father will donate the kidney she needs, but not unless he's here in the United States. So what that means is there's two scenarios. I want you to think about it this way. There's two scenarios going on, and that's what this problem is. There's two arrows. Okay, both going on at the same time. So really the problem is a dot. Okay, of two scenarios, two arrows. So I want you to think about it this way. Okay, now it says that but unless in here. So here are the two scenarios. And really, I suppose the order of them does not really matter. So just think about it. So either one of these arrows could come first. Let's take a look at this. If he's here, what's he going to do? Oh, he's going to donate that kidney. If he's not here, what's he going to do? Oh, well then he's not going to donate that kidney. That's what this is. That's what this means when it says he will donate the kidney she needs. Okay, but not unless she's here. Okay, or but not unless he's here. That's what's going on here. It's saying if he is here, he'll do it. If he's not here, he won't do it. There you go. Not as straightforward as I would like, but hopefully when you see it formalized, it actually makes sense as it is. Let's take a look now at H. H says, no receipt will be furnished except by written request. Now, I suppose there's two ways of looking at this one. I'm going to do what I think is the most obvious here. Okay, but there's really two ways of thinking. I want to preserve the negations here. So here's what I've got. Except is another way of saying unless. So that's the way I'm going to look at it. So whatever follows unless then, and in this case except, goes on the left side of an arrow. So I'm going to go ahead and draw an arrow here with a squiggle in front of it. Okay, so what follows except? W, and I'm going to stick a squiggle in front of it. Okay, what's left? There will be no receipt will be furnished. So in other words, if you don't have a written request, then you won't have a receipt furnished for you. So in other words, another even simpler way of saying it is, if you don't ask for it, you're not getting a receipt. Okay? Now another way you might look at this one is, so if you have a receipt, then you asked for it. I would, as a translation, I think I would accept this because the meaning is identical here. In fact, we'll find a way later on how to move from this to this and vice versa. We're not there yet, but if your intuition was to translate it this way, I wouldn't mark this wrong. So if this seems what's natural to you here, hey, if you have, in this case, it'd be if you furnished a request, you had a receipt furnished for you, then you sent in a written request. Okay, if you have the receipt, then you asked for it. Fine, I would accept that. But if negations are there, my tendency is to preserve the negations if they're there in the actual English language. All right, preserve them. Don't do the deduction here. But here at this point, with what you know now, if that's what your gut feeling is to write out, I wouldn't mark it against you at this point. Okay. Now let's take a look at I. I'm not going to expect you to be able to do, but it's way simpler than it looks. And for whatever reason, your book is quoting Kofi Annan here, being verbose. So listen, if all of us in this hall can make this organization lean. So look, it starts with an if. That means there is an arrow in here. I'm not going to write the arrow yet because there is a ton of stuff on the left side of this arrow. Okay, so look, if we can make this place, the United Nations, leaner and more efficient and more effective, more responsive to wishes and needs of its members, and more realistic in its goals and commitments. Whoa. Only then and only then. So here he actually pulled a sneaky move. It started out with that if, and then he said, then and only then. What does that mean? It's actually a double arrow for which all this stuff could be on the left, could be on the right. So here's one side. I'm going to keep going, though. We'll worry about the dyads in a minute. Then and only then will be able to serve both this organization's high purpose and the planet's best interests. Well, all that is definitely on one side of the double arrow. What are we doing with all of this? Yeah, this actually, all of this here is all on, here it's the left side, but again, lefts and rights when it comes to double arrows is kind of arbitrary. All of this is going on one side of the double arrow. But notice it's all ands. So it really doesn't matter how we group them together as long as it's dyadic. So what I'm going to do is I'm just going to go ahead and start sticking them together in bunches of 2s. Okay, and then we'll see if what else I need to do to make it dyadic from there. So let's see, we've got that one and that one, that one and that one. And then we got that C just dangling there. That's fine. Okay, now is this dyadic? No, actually now it's quadratic. Look, we got this stuff, this stuff, this stuff, and this little C dangling over here. So let's go ahead and let's group these together, just because. Okay, and again, how I'm grouping these doesn't matter as long as at the end of the day it ends up being dyadic and well formed. Okay, so now, is this dyadic? No. I have all of this, this, and this. Now it's triadic. So what I'm going to do, I'm going to zoom out one more layer and put this stuff in braces. Here we go. There we go. I really make that a little bit tighter. Just slightly tighter. I really bunch these together too much. There we go. So look, now I've got all this for this dot. There's its left side. There's its right. That's dyadic. Still dyadic. Let's do that again. So what about the left side? Now look, it's all ands. So it really doesn't matter where we put the parentheses. So let's go ahead. I'm going to go ahead and just do it this way. Sets of 2. Okay, there we go. Tie that up just a little bit more. There we go. Now, is this dyadic? No, it's quadratic. Look, I got this thing, this thing, this thing, and this little C dangling here. So here's what I'm going to do now. I'm going to say, okay, now this is for that. We're focusing on trying to make the left side of this double arrow work and be well formed. So let's go ahead, let's group these together. Now remember, since it's all ands, it really doesn't matter how we group these together. Let's do this. There's that dot in the middle between them. I want to make sure that's there. I kind of bunched these together, but there we go. Oh, these are bunched together. Now, the left side of this, is this, like, at least here, is this dyadic? Yeah, it is. The left side is dyadic. The whole thing is not dyadic just yet because I've got 3 parts. I end up having this thing and this thing and this thing. But no, I need, because of this, if this is dividing the whole thing, we need to make sure that it's dyadic. So it's just the left side by itself. If I were to cover this up, this is dyadic. So what I need is one more layer out. Some impressive packaging. Now, check it out. Look, for this double arrow here, this is finally dyadic. Because look, here's the left side of this big thing. Here's the right side. So this is finally dyadic. This works. I don't think I'm going to give you one this robust, but it's not as hard as it looks. Okay, let's take a look now at 3 in this chapter, 3A, B, and C, pages 86 to 87. All right, let's start with 3A here. This one's on page 86. Actually, a little bit goes over to page 87 as well. So here's the setup. Here's what we got. Now, I've already got over here, here's going to be our approach. I talked about this earlier. Here's now the rule set and the recommended order. So look and see, arrow out, modus tollens, double arrow out, that's a new double arrow in. These are, if you can do them, you probably should. Okay, and out as well. These are, if you really need to do them, and then these are emergency use only. So these should be last resorts. Don't start with these. So let's see, any arrows? No. Any double arrows? Yep. There and there. So what are we going to do? Break them down. Let's start with the first one. I'm going to start with the first one. And you could actually break down the second one first, and that would be fine. That first one breaks down into AOB, BOA. That's double arrow out on line 1 for both. Okay, now we've got, Even though I know I can break down line 2, I'm just going to do a quick check. I've got 2 arrows now. Do I have left side matches? No. Do I have right side contraries? No. So no arrow outs or modus tollens are happening yet. Okay, so let's go back up to what I know I can do. Arrow out, no. Modus tollens, no. I just said that. Double arrow out, there's that one I've been able to do since the beginning. On line 2, that gets me C arrow B and also B arrow C. Okay, those are double arrow out on line 2 for both. Okay. Now I got, look, a total of 4 arrows here for which I have no left side matches and no right side contraries. There does seem to be some overlap though. That might come in handy. So let's go down the list. Arrow out, nope. Modus tollens, nope. Double arrow out, nope. Double arrow in, yeah. But you would only end up building things that we already have in line 1 and line 2. And out, not happening. And in, no reason to do that. Double negation, no reason to do that. Is our goal an arrow? Yep. So what do? Provisionally assume the left, get the right, and that's the situation. So that we start a side quest. Okay, so we're going to get A as a provisional assumption. Okay. And the side quest here is get C. Okay, because what we're saying is, let's just pretend if we get this, will we get this? And if we can get that, we can prove that we can shove the arrow in there, that the conditional proof works. Okay, or that the conditional works because we've proven it. All right, so now with the A in play, can I do an arrow out? Yep. There's that. Look at line 3, A arrow B. Now I finally got that left side match. What does that get me? B. Arrow out, 3 and 7. Now I have a choice here. You may notice, can I do another arrow out with this B in play? Yeah, I can do 2. Okay, I can go, 4 and 8. I wouldn't do that. And here's why. If you do that, you'll get A, which you already have. So we have no reason to go back and get another A, because we have A. So is there another arrow out I can do? Mm-hmm. Look between 6 and 8. What does that get me? C. Arrow out, 6 and 8. And there we go. Look, this tidies this up. I said we're going to provisionally assume A and get C. We did it. So now we can zoom out and say that's a thing. Yep, if you start with A, it will get you C eventually. How so? Arrow in. Where did it start? 7. Where do we stop? 9. Let's take a look at 3B. All right, now time for 3B on page 87. Okay, so first take a look. So I've got it set up here. We got D double arrow E, E arrow D, arrow G arrow F, D arrow E, arrow F arrow G. And we're trying to solve for F double arrow G. F if and only if G. Okay, these are the moves we've got in play in the recommended order. That hasn't changed any. So let's see. First of all, do I have arrows? Not in parentheses? Yep. Left side match. Remember the left side here, E arrow D. If I had a full left side match for that, I don't. That's not going to work. Left side match here? No. Okay, right side contrary? No. Right side contrary? No. Okay then. Moving on. Can I do arrow out and modus tollens? Can I do a double arrow out? Yep. Right here. Double arrow. So let's unpack it. That gets us D arrow E and E arrow D. Okay, and that is double arrow out on line 1 for both. Okay, go back to the top of the list. Can I do an arrow out now? Yep. Take a look. So look right here. This E arrow D that I just unlocked is actually the left side match of line 2 of this arrow. There it is. And look, actually, in line 3, the D arrow E that I've got, we just got the left side match here in line 4. So they're bigger, but it still works the same way. It's the right key. So let's start with this one that comes in line 2. What does this unlock? I got the left side match. It unlocks G arrow F. Okay, arrow out, 2 and 5. And also here, again, line 3, we just got the left side match in line 4. So what does that unlock? F arrow G. Okay, arrow out. In this case, 3 and 4. All right. Go down the list again. Arrow out. Oh, I got new arrows. I got 4 of them. Doesn't seem like I have left side matches or right side contraries though. So keep going. Double arrow out. Can I do any more of those? No. I already broke down all the ones that I could. Double arrow in. Now, remember at this time, what are we trying to solve for? F double arrow G. And I'll say this: there are a few exceptions to this, but kind of like when I said this a couple of chapters ago, or actually, like for quiz 3, like if the thing you're trying to solve for is a dot, if it's a conjunction, probably the last move is going to be an and in. There are exceptions to that, but I'll say this here too with double arrows. If you're trying to solve for a double arrow, there's a high probability. Okay, there are exceptions, but a high probability that your last move is going to be a double arrow in. Now, in order to make this double arrow, think about double arrow in. What two things would we need? We'd need F arrow G, and we'd need G arrow F. Do we have those? Yep, we literally just got them. So what can we do? Bring them together. F, double arrow G, double arrow in, 7 and 6. You could say 6 and 7 there. That's just as fine. 3B is done. Let's take a look at 3C. Let's take a look here at 3C. So we got H double arrow I dot J. And we've also got I arrow H, and we're trying to solve for H double arrow I. So I said this a moment ago on 3B as well. Look, we're solving for a double arrow, which means in all likelihood, we are probably going to do last move double arrow in. Probably. Let's see. And also, let me go ahead and preview here. What two things would we need to make that? We'd need H arrow I, and we'd also need I arrow H. Now take a look. Look at line 2. We already have half of what we need. So if it's true, maybe there's another way to solve it where we don't need to do this, but we already have 50% of what we need to make this double arrow in happen. So let's just go around the problem, like doing our stuff normally, and see how it works out. So first of all, arrows not in parentheses. Yep. Does that lead to an arrow out or modus tollens? No, it doesn't. Okay. Do we have a double arrow not in parentheses? Yes, we do. That's this. Okay, so let's go ahead and unpack that. That gets us H arrow, I and J. That's one of those double arrow outs. Double arrow out, line 1. And we also get I dot J, arrow H. Also double arrow out, line 1. Okay. Now look, I've got new arrows here. 2 of them. Left side matches? Nope. Right side contraries? Nope. Can I do another double arrow out? Nope. Double arrow in? I could, but it only gets me what I already have. And out? There are some dots there, but they're in parentheses, so I don't have access to them. And in? Again, you can. But any of those are going to make something long and complicated. And that's not what we're going for. Double negation? Not worth doing. Is our goal an arrow? And then it's a double arrow, but I already said what we need to build that are two things. We need I arrow H, which we already have, and the other thing we'd need would be H arrow I. Do we have that? We don't have it, but it's an arrow. So if this is what we need to get, and again, we're already at 50% completion here because we got I arrow H. If we could provisionally assume H and get I, okay, this, then we could build this arrow, link it up with this with a double arrow in, and bam, we've got this. So let's give that a try. So again, what we're going after, we're going to try and get H arrow I. If we can get it, then we can double arrow it in, plug it into this, and build this. Let's just see if we can. Well, how do we do an arrow in out of nowhere? Because we say so. So check it out. As long as you follow the rules, let's indent and start a side quest. So that arrow, we're going to provisionally assume the left side. That would be H. Provisional assumption. So what's the side quest mission here? Get I. Do that. You prove that arrow, and then we can just slap them together with a double arrow in. Okay, so now with this H in play, can we do an arrow out? Yep. 3 and 5. That gets us I dot J, arrow out, 3 and 5. Cool. Now, can I do another arrow out? No. Modus tollens? No. Any more double arrows? Either break out or build? Not yet. Do I have a dot here, not in parentheses? Yes. And I can slice it down. It gives me two things. So we have an option here, by the way. So I'm just going to explain what to do. I'm going to go ahead and get I out and out. Okay, where did that come from? Line 6. Now you might be thinking, hey, that's what I was in my mission to do. I was supposed to solve for I. So yeah, you can be done with this side quest right here, like I. But if you're like, what do I do with the J? Where do I put it? And that's really bothering you, just stick J there. That's fine. But it's not necessary. So I'm going to say this is actually a superfluous step, but it's not wrong. But if you feel uncomfortable not finishing it, that's okay. But we can stop here actually in line 7. So In fact, I'm going to get rid of the number here. I'm just going to blur this out. This is just an extraneous step. I'm not going to count it, but if you put it here, that's totally fine. Okay, but this means here 5 through 7, we did it. We provisionally assumed the left side of our goal here, and we got what we set out to get. We got I. So now I'm going to zoom out. So this is going to be my real line 8. So yeah, you get H arrow I. That's a thing. Well, how do we prove that? We stuck an arrow in there. By provisionally assuming the left side in line 5, and we got the I in line 7. Now, if you stuck that J in there and you called this line 8 and you're like, no, that's part of it, I would accept that. That's perfectly fine. Okay? So now, what do we do? Look at line 2. So like if we go down the list, look, arrow out, no. Monotones, no. Double arrow out, no. Double arrow in, yes. Look at line 2. I arrow H. Look at line 8. H arrow I. We got the two things to build our goal. H double arrow I. So in fact, that's what we do. Line 9, H, double arrow I. That is a double arrow in. Where do we get those pieces? Line 8 and line 2, and this problem is done. All right, let's take a look at number 4. Okay, number 4 is found on page 87 as well. Here's what we got. Now I'm going to go ahead and preface this by saying it uses the word not here as one of its words that we want to use as a statement, and it doesn't mean a negation here, which is kind of stupid. But we're going to just roll with what the author of your textbook has done. So let's see. Doctor-assisted suicide for patients not on life support should be legal if and only if, bam, double arrow. So doctor-assisted suicide for patients not on life support should be legal if and only if doctor-assisted suicide for patients on life support is legal. Okay, assumption number 1. The latter, so that means not the former, not the first one, the second one, is legal. Okay, the latter is legal. Assumption number 2. So, the former should be legal as well. There we go. That's it. This one's pretty straightforward. Remember, our moves in play. Arrow out. Most tolens. Double arrow out. Double arrow in. And out. And then if we need to, and in and double negation. And if we really need to, arrow in and indirect proof. Okay. So, do we have an arrow not in parentheses? Nope. So arrow out and modus tollens are right out. Do we have a double arrow not in parentheses? Yup. There it is. What does that break down into? 2 things. N arrow O, which we're not going to need, but I'm going to go ahead and break it out anyway. I think this is a good habit to make. It's just like with ands when you break them apart. With double arrows, break them out. How do I know I'm not going to need it? You'll see in the long run, we'll never use line 3. And then we also get O arrow N. Both of those are double arrow out on line 1. Okay, now, do I have arrows not in parentheses? Yeah, line 3. But also line 4. Do I have left side matches? With line 3 I don't, but with line 4 I do. Look, there it is. That unlocks what? N. Arrow out, 4 and 2. So look, we did it. We got what we came for. But look, we never needed line 3. In fact, you don't even need to really get it out. I do. Like I always, if I have stuff to break down, I always break it all the way down. But you might realize, oh, I'm not going to need this, and not get it anyway. So you could do this in 4 steps instead. That's fine. Okay, let's take a look now at number 5. Okay, number 5, page 87. T-shirts with Christian messages should be permitted just in case. All right, so just in case means double arrow. So here's what we got so far. Line 1. T-shirts with Christian messages should be permitted just in case. So double arrow. Shirts with satanic messages are allowed. Okay, assumption number 1. So if shirts promoting Christianity are allowed, then shirts promoting Satanism should be allowed, and vice versa. If shirts for Satan are allowed, then shirts for Christianity should be allowed. So it goes in either direction. Okay. However, it says since the latter are not allowed. Okay. So actually, it's putting a assumption here and the conclusion all in one. So that whatever follows since is another assumption. I'm never going to do that to you, but the author of your textbook will. Okay. The latter are not allowed. So satanic T-shirts are not allowed. Therefore, so here's what we're solving for. Christian T-shirts shouldn't be allowed either. Okay, let's do the work. Do we have an arrow here not in parentheses? We don't. Although you might mistakenly jump to line 3. Oh, that's modus tollens. It's not, because this is a double arrow. There is a way. There's sort of a biconditional tollens that we can do later on, but we don't have that yet. So don't mix up the double arrow with the regular arrow. So let's see what we got. Arrow out can't happen. Modus tollens can't happen. We do have a double arrow though. That breaks down into two things. We get C arrow S. I'm sorry. We get C arrow S. Yeah, C arrow S, and we get S arrow C. Double arrow out on line 1 for both. Okay. Now we have two fresh arrows here. This one, this one. Now, do we have a left side match for this? No. Do we have a left side match for this? No. Do we have a right side contrary for this? No. Do we have a right side contrary for this? Yes. Look, we got an arrow. Its right side is S. We have its contrary right here, not S. Squiggle S. That means we can get the contrary of the left side, that's modus tollens. That would be squiggle C, which is what we're trying to get, which means we get it modus tollens 3 and 2. Problem's done. On to number 6. We've got this. The red dish is the supper dish if, we see that IFF, that stands for if and only if. It's a short way of putting it. Okay, so the red dish is the supper dish if the yellow dish is the water dish. So there we got R, that's line 1, R, double arrow, because that's the if. The yellow dish is the water dish. Okay, assumption number 1. Okay, assumption number 2. There is water in the yellow dish. Okay. Assumption number 2. If so, if what is so? If there's water in the yellow dish, then the yellow dish is the water dish. Okay? That's assumption number 3. And so, which means the red dish must be the supper dish. So prove R. All right, let's do it. First of all, any arrows not in parentheses? Yep. So immediately, look, we can do an arrow out. First thing. That hasn't happened in a while. Why? Arrow out, 3 and 2. Okay, let's look now. Another arrow out? No. Modus tollens? No. We got a double arrow here. Let's go ahead and break that down. That gets us two things, one of which we're not even going to need. We get R arrow Y, we get Y arrow R. That's double arrow out on line 1 for both. Okay, we got new arrows here now, not in parentheses. Do we have a left side match for either one of these? Yep, look, line 6 has a Y on the left. We got that Y in line 4. What does that get us? Arrow out. We get R. That's arrow out, 6 and 4. Hey, that's what we're trying to get. Problem is done. On to number 7, page 88. Okay, number 7 is one with a glossary. That's kind of complicated, where you got, C stands for cab as a theorem, L stands for LCAB as a theorem, F stands for fab as a theorem, and it says if, I'll just read it as it is, but I've already done it. If cab is a theorem, then LCAB is also. And if LCAB is a theorem, then so is fab. Moreover, that's there for no reason, it's just the beginning of a new sentence. If fab is a theorem, then cab is too. This proves that, and here's the conclusion that I did not put up yet. This means that cab is a theorem if and only if fab is a theorem. So we're solving for C double arrow F. Okay, that's what we're solving for in the end. Now I'll go ahead and tell you, it's a double arrow, so that means there's like a 90% likelihood, or a high likelihood, the last move is going to be a double arrow in. In fact, it will be. We're going to spoil that for you here. But let's do the problem. Okay, so I've already got our moves up here. Let's go through it. Okay, do we have any arrows not in parentheses? Yep, line 2. Any left side matches? F by itself somewhere? No. Okay. Right side contrary somewhere? No. Any double arrows? Actually, none. So, and we can't build any either. Any dots? Yeah, there's a dot. What does that allow us to do? Slice it, and we get what two things? We get lines 3 and 4. We get this thing and this thing separate and freed from their parentheses. So we're going to get C arrow L and L arrow F. Okay? And that's and out on line 1 for both. Oh, look, new arrows, not in parentheses. In spite of that, no left side matches. Okay, so at this point, it actually seems kind of stuck. So here's what we need to think of. I already told you that we need to get this double arrow, C double arrow F. Now, in order to get that, we need to think, what are the two things we need? Okay, we need C arrow F. Do we have that anywhere? Nope. We'd also need F arrow C. Do we have that anywhere? Ding, ding, ding. Look, line 2, we've already got it. So we're already at 50% completion for what we need to make this. What we got to do then is we got to get C arrow F. We do that, we're good. So in fact, that C arrow F, how could we prove it? Well, it's an arrow. So all we got to do here, we got to just provisionally assume this and get this, and if we can do that, we get C arrow F. Let's do it. Let's start the side quest. Line 5. Provisionally assume C, and go after F. Okay, can I do an arrow out? Yep. That C is the left side match to line 3. That gets out L. Okay, arrow out, 3 and 5. That L unlocks the F. Ding, ding, ding. That's what we were going for. That was done real quick. So look, F. Arrow out. 4 and 6. Side quest complete. We started in line 5. We're done in line 7. So we can zoom out and say, in line 8 here, yeah, if you start with a C, it'll totally lead you to F. Also, arrow in. Start at line 5. Finish the mission in line 7. And now look, all we got to do to get this C double arrow F is do a double arrow in between line 2 and line 8. Check it out. So I can say C double arrow F. Double arrow in line 8 and 2. If you said line 2 and 8, that's just as fine. Okay? So that's number 7. Number 8. Let's begin. Okay, here's what we got. Line 1. Oh, this is one of those fancy logic sounding ones. It's not as complicated as it looks, but it's verbose. If, that means arrow. First word, if. If propositional logic is adequate for evaluating the argument, that comma drop there means that all that just happened, that's on the left side of the arrow, so it's just going to be A by itself. So then, that's what that comma drop was doing. The English argument is valid just in case, up to the right side of this arrow is a double arrow. Okay? So that means the English argument is valid just in case the symbolized argument is valid. Okay? Assumption number 1. Okay? Line 2. The English argument is valid, but the symbolized one isn't. Okay? It follows, so here's what we're solving for. It follows that propositional logic is inadequate. Inadequate for what? Evaluating the argument. So if A stands for it's adequate, now the author of your textbook does not italicize for negations or any indicators of any kind. So if I say something was adequate and I want to go it's inadequate, what does that mean? We're solving for squiggle A. All right, let's do the work. Arrow not in parentheses? Yep. Left side match? Nope. Okay. Double arrow is not in parentheses? There is a double arrow, but it's in parentheses, so it's locked for now. Any dots not in parentheses? Yep. Go ahead and slice it. That gets us E and squiggle S by themselves. And outline 2 for both. Okay. If we go down the list, arrow out, nope. Most holes, nope. Double arrow out, nope. It's locked. Double arrow in, can't even do one if we wanted to. And out, already did it. And in, wouldn't get us anything worthwhile. Neither would double negation. Is our goal an arrow? No. So what is there to do? Indirect proof. Our goal is squiggle A. So here's what we're going to do. We're going to visually assume the opposite of that, contrary of that, and then we're going to try and get a contradiction. Remember, contradiction is an and statement of contraries. Something and its opposite. So let's plug that in. So we're going on a side quest, line 5. We're going to say, let's just imagine that what we're going for is not true. So if squiggle A were true, we're going to pretend that just A is true. The contrary of our goal. This is a provisional assumption. Okay, the mission in this side quest is get a contradiction. That's what that sideways T means solve for this. This upside down T means get a contradiction. All right, you could read it that way. Okay, now with this A in play, can we do an arrow out? Yep, between 1 and 5. But don't forget the mission. The mission, again, in an indirect proof is find two contraries, two opposites, and stick them together. Okay? We can do an arrow out. That's going to unlock the right side of this arrow, which is going to be E, double arrow, S. Unlocked. Arrow out, 1 and 5. Okay, we'll go down the list. Can I do any more arrow outs? Modus tollens? No. Double arrow out? Yep, that's new. Break that down, we get two things. And that actually gives us some options. We get E, arrow S, and we get S, arrow E. Okay, that's double arrow out on line 6 for both. Now, we actually have two options here. Okay, so look now. We've got two fresh arrows, not in parentheses, for which, and I'll just say, when I say we got two options, we can actually do an arrow out right now, which I prefer to do. We all have a modus tollens available. I'll say this. Your exact results will be different, but you'll actually finish the problem in just as many steps. But I'm going to stick to the list, and if an arrow out comes first, I'm going to do that first. But even if you didn't see the arrow out, a modus tollens could get you out of this as well. Okay, so if we do the arrow out here, again, the arrow out 7 and 3 is what I'm thinking, we're going to get S. Now, if you did the modus tollens instead, you see that you've got E arrow S and you've got squiggle S, you can get squiggle E, and your contraries will be E and squiggle E. Since I'm going this route, it's going to be slightly different, but like I said, it would be the exact same amount of steps. Okay, so I've got S. How do I get that here? This S, the way I did it here. Arrow out, 7 and 3. Okay. Do I have two contraries? Ding, ding, ding. Okay, remember, that's the mission. S, squiggle S. There they are. All I got to do now is stick them together. S and squiggle S. That's a contradiction. So how did I get them? Pieces came from 9 and 4. And so this side quest is complete. Okay, so I'm going to zoom out here and say, yeah, squiggle A is a thing, because if it weren't, it would lead to nonsense, because contradictions are stupid. Okay, that's indirect proof, 5 through 10. All right, let's do number 9. Okay, 9 is on page 89. So, line 1. Restrictions on police powers will be viable if, so that means there's a double arrow, so it'll be viable, double arrow, if what society remains civilized. Assumption number 1. Hence, now that that hence there means, here's what we're solving for. We're already ready for the solution. Hence, if society does not remain civilized, so it's an arrow, if society does not remain civilized, then police power restrictions will no longer be viable. All right, let's do the work. So here, do we have any arrows? No, so arrow out, modus tollens is not happening. Double arrow? Yep, not in parentheses. So that breaks down into these two things. We get V arrow C, and we get C arrow V. Double arrow out on line 1 for both. Okay, now we got two fresh arrows here, not in parentheses. Can we do an arrow out there? Do we have a left side match? No. Right side contraries? No. Can we do another double arrow out? No. Can we do a double arrow in? Yeah, and we'd get V double arrow C, or C double arrow V. That's not this. Do an and out? No. And in a double negation? Yeah, but it doesn't get us anywhere. Is our goal an arrow? Indeed it is. What does that mean? We're going to provisionally assume this, and try and get this in a side quest. So let's do line 4. We're going to provisionally assume squiggle C with the mission of getting squiggle V. Let's do it. So now with this in play, can we do an arrow out? No. Can we do a modus tollens? Yes. Look, this arrow right here in line 2. What's its right side? C. Look, we got a contrary to the right side. That means we can get the contrary to the left side. So look at it. That gets us squiggle V. How so? Modus tollens 2 and 4, and this is like one of the quickest arrow ins you could possibly do. We provisionally assumed the left side and got the right side immediately, which means we can zoom out and say, yeah, if you have squiggle C, you can totally get squiggle V. How so? Arrow in. And I'm still going to say 4 through 5. even though they're right next to each other, just because that's what we do with arrow ends. All right, number 10 is hefty. We got a lot of assumptions at the start. We got a lot of places to go. So let's break it down. So line number 1, if. Okay, that means there's an arrow, definitely. Let's go ahead and stick that arrow out there. So whatever follows if goes on the left side. So if brain phenomena are identical with mental phenomena, comma, that comma drop means that's where the left side ends, so we've got this. If brain phenomena are identical with mental phenomena, then the former's having spatial location constitutes a necessary and sufficient condition for the latter's having spatial location. Now, I really don't like the way this problem does it. I'll say this. The necessary and sufficient condition in there means that there's a double arrow on the right side. Okay, so I know that much. Okay, necessary and sufficient condition. Well, here's the thing. I would underline these things here to make it clear, but here it doesn't do that. Like, well, what goes on the left side of this double arrow on the right? It actually tells you in later statements what it's going to be. I'll just say this. The left side of this double arrow where it says the former's having, that's brain phenomena are spatially located. That's B. Okay? And on the right side, mental phenomena are spatially locatable. This. That's assumption number 1. And what it's saying here is this. Like, when it comes to stuff going on in the brain, is that the same thing as stuff going on in the mind? And also, if stuff's going on in the brain, like let's say I have a thought about something that happened in the past, like, oh, I'm remembering my first day of kindergarten. Is there a specific spot where that's happening in the brain? And also, if so, is there a specific spot, like in space, where that's happening in the mind? Like this synapse is firing. Is that where the memory actually is? That's what this is getting at. Okay, it's saying like our brain's the same thing as minds. Brain state's the same thing as mental states. Okay, so assumption number 1. Okay, assumption number 2. Brain phenomena can be located spatially. Okay, we do that all the time when you see neurologists talking about this part of the brain fires up, like lots of things are going on when you think about this. Or this is the part of the brain that does this, and so on. That's what that would be. Okay? And then we've got this. Provided that means if. Okay, so there's an arrow here. Provided that, so if mental phenomena are spatially locatable, okay, that is, things going on in the mind can be found in space. Okay, not the brain, the mind, like stuff in your mind. Like I'm thinking right now of a thought. Does that thought exist somewhere? Okay, if that is the case, then it will be meaningful to assign a spatial location to a thought. Okay, spatial location to a thought. Okay, like in terms of like a thought going on in the mind. Okay, like your thoughts in your head. Okay, are they in specific places? Now, I'm not saying like is there like a file folder in your head somewhere, but something kind of like that. Like is there a specific place where I'm having a mental state thinking about something? Like is that thought going on somewhere? It's not just in my brain, but in my mind. Like could we could put X, Y, and Z axes and say this thought that you're having, or like a memory or something like that, or even you thinking about like, oh, this is stupid. That thought you just had about this being stupid, is that located somewhere? So if mental states are spatially locatable, it will be meaningful to assign a spatial location to a thought. Assumption number 3. Cool. I like this. Line 4. It is not meaningful to do this. So is it meaningful to assign a spatial location to a thought? No. Because where does that get you? Your thoughts are located where you can't find them. Okay, we can't. It's not like we can see stuff going on in the brain, but we can't see stuff going on in the mind per se. Yeah, I know. Like when we're looking at people, we can tell like, oh, they must be angry because they're making an angry face. At least in terms of like what the mind is, we can't really peer into that and see what it is. Like we can do with other forms of data. Okay, like stuff on a Blu-ray. It's all data that's on there, but we can take that and decode it and figure out, oh, this is what data is on here, whether it be a movie or video game or something like that. We can take that data and decode it based on various kinds of programming systems and languages. It doesn't seem like the mind really works that way, so that's why I'm saying it's not meaningful to do this. So, it is false that brain phenomena and mental phenomena are identical. So you might be tempted to go, oh, that's B and M. No, look back at the very beginning. I stands for brain phenomena and mental phenomena are identical. So what we're actually solving for is squiggle I. Whew. Now, I wouldn't do this to you. All right, there's a lot of stuff going on in here that I think is very confusing the way it's been presented. And like I said, we'll go over some for quiz 5 that in this video. Like there will be some, and you'll see it in the link down at the bottom where it says here's what these things are. There'll be some quiz 5 problems that we'll go over. But now with this in play, let's do it. So first of all, do we have any arrows not in parentheses? Yep, we got 2. Okay, can we do an arrow out? Nope. Can we do a modus tollens? Do we have a not or squiggle B double arrow M? No. Do we have a squiggle T sign? Yeah, we do. We can do a modus tollens right here. What does that get us? Line 5, squiggle M. Modus tollens, 3 and 4. And I'll say this. Now this one is with a little less certainty, but I'll just say, if you're doing a modus tollens early on in a problem, you're probably going to use this thing later on, and it's going to be a big deal. So just remember that this is here. So that being said, great. Can we do another arrow out? No. Modus tollens? No. Double arrow out and this is locked. Double arrow in? Can't even do it. And out? Nope. And in? Sure, but no, let's not. Double negation? Again, sure, let's not. Here's our goal, an arrow? Nope. So what does that leave? It's indirect proof time. So our goal is squiggle I. What are we going to do in an indirect proof? Provisionally assume the contrary of our goal. That's going to be just plain old I. And what's the mission? We're going to solve for any contradiction. Any two things that are contraries. Something at the exact same thing with a squiggle in front of it. That's what a contradiction is. That's the mission. Let's do it. Now with this I in play, can we do an arrow out? Yep. 1 and 6. That's going to unlock this right side, free it from the parentheses. That gets us B, double arrow M. Okay, and that's arrow out, 1 and 6. Now, something that could happen here, you might make the mistake of going, oh, this is a left side match. I can go ahead and get out the M. Nope, that's a double arrow, so don't make that mistake. At least with the rules that we have now, we can't do that. So can we do an arrow out right now? No. Okay, so don't make that mistake of thinking that's the left side there. I can just go ahead and unlock that. We're going to use this in a minute, but not just yet. So can we do modus tollens right now? No. We do have a fresh double arrow here. Let's go ahead and unpack that. That gets us two things. B arrow M, M arrow B. Okay, that's double arrow out on line 7 for both. Okay, now to my arrows. Now can I do an arrow out? All right, again, this is actually like one that we did earlier. I actually have an arrow out option. Look, I have a left side match with line 8 and line 2. And I actually have a modus tollens option between line 5 and line 8. But my preference is always to do arrow out first before modus tollens if I can. So if you do it the modus tollens route, that's perfectly fine. Not wrong at all. Worth just as many points, you'll be done in just as many steps. So it's no more efficient. However, for the most part, if you follow this, we'll call it program up here, you will always get the most efficient results. I'll say 99% of the time. Just as a general rule, follow this list in this order. So I'm going to be consistent and do that here. So I'm going to say, yep, can I do an arrow out? Sure. What does that get me? M. Arrow out. 8 and 2. And remember, once you start an indirect proof, one of the things you want to look for is, do I have two contraries? What we do right now. There's M, squiggle M. There they are. What do I need to do? Put them together. M and squiggle M. And in 10 and 5. Side quest complete. So what I can do is I can zoom out here and say, yeah, squiggle I, totally fine. Indirect proof. Where did we start it? 6. Where did it stop? Line 11. Now, if here, instead of doing this arrow out that we did in line 10, and you did the modus tollens, you would end up getting squiggle B if you did a modus tollens between 8 and 5, and then you'd end up putting B and squiggle B together, but you'd be done by step 12 with the exact same thing. The only difference here is you'd say modus tollens here, and it'd be a different and in here, but it works just the same. Number 11 says this. We're translating in, and then we're going to solve the proof. Backup lights are needed. Okay, backup lights are needed only if, that means go ahead and slap that arrow down real quick. Only if the car is in reverse. Assumption number 1. Okay. because they're connected to the transmission. They are on just in case the car is in reverse. Okay? So the backup lights are on just in case the car is in reverse. So your backup lights, those little white lights, so if they're on, then the car's in reverse, and if you're in reverse, then the lights will be on. Of course, given that the lights are actually working and everything's connected and stuff like that. Okay, you know this. That's how you know somebody's backing up in a parking lot. Oh, they must be in reverse. Okay, because if they're in reverse, then those lights are on. If those lights are on, they're in reverse. Assuming everything's working correctly. Alright, then this. If they are on, only if the car is in reverse. So if they are on, only if the car is in reverse. That, because that only if means the little arrow in there immediately as soon as we see that only if. So, but it says, it said, if they are on, only if the car is in reverse, means that all this is on the left side of an arrow. Then what? Then they use very little power. Third assumption. Therefore, that means here's what we're solving for. The backup lights are on if needed. So if needed, the lights are on. Yet, dot. Yet, they're using very little power. Okay, here we go. That's the setup. Now look, the goal is actually a dot, which means there's a 99% likelihood that the final move is going to be an and in. In fact, it will be. All right, so go ahead and anticipate that. That means if I know the last move is going to be an and in, I'm going to get an L by itself somewhere, and I should have an N arrow O somewhere. And I'm going to combine those two things. So I know that's what I'm hunting for. This thing by itself and this thing by itself. All right, with that in view, let's do the work. Do I have arrows not in parentheses? I sure do. But can I do anything with them? Nope. No left side matches. No right side contraries. Moving on. Do I have a double arrow? Not in parentheses. Yep, right here. So I can break that down. Let's do that. I get O arrow R and R arrow O. Double arrow out on line 2 for both. Okay, so I got 2 fresh arrows here. Now, do I have left side matches for either of these? No. Right side contraries for either of these? No. But take a look at the arrows that we already have. Do I have a left side match for this? No. Right side contrary for this? No. But in line 3 I had an arrow as well. Do I have a left side match for this? O arrow R? I literally just got it. Look, there it is in line 3 and line 4. Like, look, line 4 there is the left side match to here. That's going to unlock the L. So L. Arrow out, 3 and 5. Cool. But now, take a look. That's half of what I need. So think about this. With this and again, I need 2 things. I need to get N arrow O. I don't have that. And I also need to get L. This checks out. I just got it. So the final part of the problem where I said there's and in, it's going to be and in 6 and something else. Now take a look. Can I do any other arrow outs? Modus tollens's? No. Any more double arrows I can break down? Make? No. And outs? No. And ins and double negations? Sure, but it doesn't go anywhere. Is my goal an arrow? Now, no, our goal is an and, but the thing I need right now is an arrow. I need this. Because then I can just say this and that L, which I already have, and I'm good to go. This is my goal right now. It's an arrow, so what I'm going to do is I'm going to provisionally assume the left and solve for the right. So let's begin that quest. Line 7. Let's plug in N, and our goal is let's get O. We do that, then N arrow O is a thing. Now with this N in play, can I do an arrow out? Yeah, with that arrow way back in line 1. What does that get me? R. Arrow out, 1 and 7. Okay, and now with that R, can I do an arrow out? Yup. This is the left side match for that line 5. What does that get me? O. Arrow out, 5 and 8. Ah, we did it. Look, we set out to get O, we got it. So if N, then O is a thing, which means I can zoom out and say, yep, N arrow O. It works. You can stick an arrow in there. Okay, we started that process in line 7. We completed it in line 9. And now what I can do, look, the thing I'm solving for, I need n arrow O and L. There's n arrow O, there's L. So all I gotta do in line 11 here is say, yeah, n arrow O dot L, and we haven't done one of these in a while, and in 10 and 6. And line 11, number 11, is done. Number 12. Let's translate. So what we've got, really, number 12 really starts on page 90. We're trying to prove that the thing that says S1 concludes with S2. So let's see, S1 is this. The city wants the property if the voters want it. So remember, whatever follows if goes on the left side of an arrow. Okay? So whatever follows if goes on the left side of an arrow. So if, in other words, if the voters want it, then the city wants the property. Oh, but it's not done. And it says, and the city doesn't want it unless. So, oh, here we go. We got and another arrow. And remember the way unless works. And the city doesn't want it unless the voters want it. So remember, unless, whatever follows unless goes on the left side of an arrow with a squiggle in front of it, which means, what's left is squiggle C. So here's what they're saying. If the voters want it, then the city wants it. And if the voters don't want it, then the city doesn't want it. Assumption number one. Not only assumption number one, that is our only assumption. All right, and then here's what we're solving for. The city wants the property if and only if the voters want it. So C, double arrow, V. That's the mission. Okay, so what we're going to do is we're going to begin this quest now. So, first of all, do we have any arrows there not in parentheses? No. The parentheses, or the arrows that we have are locked. Okay, do we have, so we can't do an arrow out, modus tollens. Do we have a double arrow? No. No, so do we have a dot not in parentheses? Yeah, we do. There it is. So what do? Let's break that apart. And that's going to free these things from the parentheses. We get V arrow C, and we also get squiggle V arrow squiggle C. Okay, and that's and out on line 1 for both. Okay, so we've got these now. Now with these fresh arrows out of parentheses, any left side matches? No. That's not going to work. Okay. So yeah, we don't have any left side matches. We don't have any right side contraries. So let's go down the list. No, no double arrows to either take apart or build. No and outs to do. We can do an and in. That doesn't make any sense. Double negation doesn't make any sense. Is our goal an arrow? No. But remember, I said this before. With double arrows, if you got a double arrow, 99% likelihood you're going to do. Last move is going to be a double arrow in. In fact, it will be here too. So, knowing that, let's think back. What two things would we need to and in to make this? We would need C arrow V, and we would also need V arrow C. We need these two things in order to make this double arrow. Do we have either one of those? Look at line 2. So we're 50% there. We're halfway there. We've already got one of them, so now we know what we need to do is get C arrow V. Okay, so what we're going to do to go after that one is we're going to provisionally assume the left, try and get the right. Let's start it. So our quest will begin in line 4. Okay, let's provisionally assume C. Okay, with the intent of going after V. Okay, so this actually goes pretty swimmingly here. Check this out. So do I have an arrow out now with the C in play? No. Do I have a modus tollens? Yes. What do I get? Okay, so look here, this line 3. I've got squiggle C on the right. I've got C in line 4. So this is modus tollens. If you have the contrary of the right side, what can you get? The contrary of the left side. The contrary of the left side would be V. How so? Modus tollens? 3 and 4. Now you might be thinking, oh, now that I've got V, I can get C out. There's no reason to do this. We already have the C. And in fact, we already have what we set out to get. Like, it's done. Look, we provisionally assumed left, and we got the right immediately. So we can zoom out and say, yeah, if you provisionally assume C, you totally get V. How so? Arrow in. 4 through 5. Okay, now look what we got. Line 7. Look, I've got the two things I needed to build that I said here. Look, I got check marks now. I got this thing, and I got this thing. Now all I need to do is put them together. C, double arrow V, double arrow in, line 6 and line 2. Or you could say line 2 and line 6. That's fine too. All right, let's take a look at number 13. 13 is actually the same problem as number 12, just in reverse. Like number 12, we started with this, and we got this. So 13, we're saying, does it work the other way? Let's do the work here. So first of all, arrows are not happening. So the first thing we can do is with this double arrow, we can break it down. We get two things. C arrow V, and also V arrow C. That's double arrow out on line 1 for both. And now that we got these arrows here, left side matches, right side contraries, neither one of those things are happening. Now take a look at our goal. Our goal is an AND, which means there is a high likelihood, a 99% probability, that our last move is going to be an AND in. What do you think? Yeah, it's going to be an AND in. Okay, it's the last move. So in order to make that, what two things would I need to get there? I would need V arrow C, and I would also need squiggle V arrow squiggle C. Now take a look at what we got. We got one of them already. We're halfway there. So now we just need to figure this out. Okay, so is this an arrow? Yeah, so if I look at the list, there's nothing else I can really do that leads me anywhere. I just need this. So all I need to do is I need to provisionally assume this and get this, and then I can build this arrow and then just AND it in with this, and this problem's done. So let's do that. So let's start our side quest here. Line 4, I'm going to say, okay, squiggle V, and we're going to go after squiggle C. Okay, so now with this squiggle V in play, do I have a left side match? No. Do I have a right side contrary? Yes, I do. Between line 2 and line 4. So modus tollens, I'm able to get, okay, if I have an arrow and I have the contrary to the right side, I can get the contrary to the left side. The left side is C, so what's the contrary going to be? Squiggle C. Okay, oh, I should provisional assumption there. Okay, to get that. Okay, which it happened immediately. So look at it. We can say, hey, modus tollens, 2 and 4, and this arrow in is done. Also very quickly. Now we can zoom out and say, yep, if you start with squiggle V, you will totally get squiggle C. Arrow in, 4 through 5. Okay, we're not quite done. Yay, we did it. We got the other thing. Now I can say, check. So what do we need to do? AND in line 3 and line 6. And we're done. So take a look. Line 3, V arrow C. And line 6, squiggle V arrow squiggle C. We'll just AND those in. AND in. Line 3, line 6. It's done. So again, just like number 12, it's this one in reverse. What that means is C double arrow V and V arrow C and squiggle V arrow squiggle C are identical. If you can go back and forth between them, it means they mean the exact same thing. That's what that means. Okay? So let's take a look next now at number 14. All right, number 14. From an episode of Star Trek, we've got this. Line number 1. Okay? He says that he's lying. This is a Star Trek episode where they make a computer basically have a mental breakdown of a computer because it can't figure out this logic problem. Or let's see why. That's line 1. He says he's lying. Okay, line 2. If he says that he's lying, and he is lying, so there's an arrow. If he says that he's lying, and he is lying, then he isn't lying. Assumption number 2. Assumption number 3. But also, if he says he's lying, and he isn't lying, then what? Then he's lying. If he said, again at the beginning, he's lying. got these three assumptions. This proves he is lying exactly if he isn't lying. It's kind of like sometimes we say in logic, like if I say the following, this statement is false. So is it true that it's false? Or is it false? Like what do I? It's that kind of thing. So here's what we're proving. So we haven't seen this yet. The phrase exactly if. It's the same thing as double arrow. So what do we got? This proves. So here's what we're solving for. He's lying exactly if he's not lying, which is ridiculous. Okay, so this is a ridiculousness, but that's what we're proving. That means lying is the same thing as not lying. Does not compute, and that's in fact exactly what happens in this old Star Trek episode. Okay, so let's do the work. We got arrows not in parentheses. We sure do. Okay, do we have left side matches here? Nope. Right side contraries? Nope. But our goal is a double arrow, and we've seen this many times before. If our goal is a double arrow, we know the last move is probably going to be a double arrow in. In fact, it will be. So what two things would we need to make that happen? We would need L, arrow, squiggle L, and squiggle L, arrow, L. Do we have either one of those right now? We don't. But that's what we need. But if I go down my list, can I do an arrow out? No. Notice tones? No. Double arrow out? No. Double arrow in? No. And out? Those are in parentheses. Can I do an and in? Double negation? Yeah, I can do both of those, but it doesn't lead anywhere. Is my goal an arrow? No, it's a double arrow, but I know that I need to get these. So what I'm going to do in two separate sets is I'm going to provisionally assume this and get this, and I'm going to provisionally assume this and get this. So let's do this one first. Okay, so line 4, let's begin this quest. Remember, we have to do these separately, so even though a lot of the stuff on the inside of these side quests is going to seem very similar, side quests are their own separate deal. So we can't mix and match between them. So let's do this one first. Let's provisionally assume L, and what we're seeking is squiggle L. Let's see if we can get it. Right now with L in play, let's see what I can do. Now, can I do an arrow out? No, but look, I have the pieces to build the left side. So I'll say we can do a modus tollens here right now. Okay? And that works. It will work. It will take a little bit longer because we have to end up making an indirect proof. There's a way to do that, but I'm just going to say right now, if you see that you got the pieces to build the left side of an arrow, go ahead and do it. So we do. We have the pieces to build it. Again, we can do a modus tollens right now. I'm actually going to say, well, since we know we can build this left side, let's go ahead and do that so we can get the arrow out of the way. Let's do it. What do we get? Line 5. S dot L. And in 1 and 4. Okay, what can we do now? We get an arrow out. What does that get us? Squiggle L. Bam. Done. How do we get that, though? Arrow out. 2 and 5. And now we can zoom out and say, yep, L, arrow, squiggle L is a thing. Arrow in 4 through 6. Okay, so we got one of the things that we needed. Now we need to get the other thing that we need. And when we do so, we can't use any of this stuff. So this is its own separate process. We need to get the other thing. So what we're going to do now is in line 8, we're going to provisionally assume squiggle L. But wait, we got it in line 6. Nope, that was a side quest. So ignore all of this stuff 4 through 6. So we're going to provisionally assume this in order to get L. And all the stuff 4 through 6 is off limits. Anything 1, 2, 3, and 7 are in play. So now, with squiggle L in play, okay, can we do an arrow out? Now the answer is no. We can do a modus tollens here. But again, we already have the pieces to build the left side of this arrow. Let's go ahead and do that. That's the wisest thing to do here. Okay, so that gets us S dot squiggle L and in 1 and 8 in this case. And now we can do an arrow out here between 3 and 9. And what does that get us? Plain old L. Arrow out 3 and 9. So we can say in line 11, squiggle L leads to L. Arrow in, 8 through 10. And then I'm just going to say over here, I'm going to put my line 12 over here. Line 12, what can I do now? Look what I got in line 7. And look what I got in line 11. This is exactly the two things that I needed here to get this. So look, in line 12, I can just say, hey, put those together with a double arrow in, L, double arrow, squiggle L. How so? Double arrow in. Where are those pieces? Lines 7 and 11. It's done. So lying is the same thing as not lying. Does not compute, does not compute. Problem solved. Number 15. Let's take a look. Line 1. Okay, this is found again on page 90. A is Elvis just in case B is Elvis. Okay, just in case, that's a double arrow. So A, double arrow, B. Assumption number 1. Okay, assumption number 2. What do we got? It is not true that both A and B are Elvis. So A is Elvis and B is Elvis? Can't be true. Can't have both of them. All right, great. Therefore, so here's what we're solving for. Therefore, it says A is not Elvis and neither is B. I don't like this translation here, so I'm just going to say it's saying this. A is not Elvis and B is not Elvis. So, and neither, just put it that way. It's the same thing as saying nor. Okay, now we put neither and nor together, it means something different, but for now we'll just go with that. It means squiggle A dot squiggle B. That's what we're solving for. Okay, with that in play, let's see what work we can do. Now take a look. The goal is a dot, which means 99% likelihood the last move is going to be an and in. So let me go ahead and put that underneath here. What two things do we need? We need squiggle A, and we also need squiggle B. So that's the quest. Okay, with that said, any arrows here not in parentheses? No. Double arrows not in parentheses? Very much so. Okay, what does that break down into? We get two things. We get A arrow B, and also B arrow A. Both of those, double arrow L on line 1. Cool. Now we got arrows not in parentheses. Okay, left side matches. Right side contraries? No. Okay, do we have any double arrows we can break apart now? No. Any that we can build? Yeah, but it just builds back into this. Or B double arrow A. That doesn't lead us anywhere. Dots that we can break apart, and this dot is in parentheses. It cannot be broken down. And in double negations? Sure, but they don't lead anywhere efficacious. Is our goal an arrow? No. So what do we do? Indirect proof. But it would be a mistake to do an indirect proof of this whole thing. So look, this is squiggle A dot squiggle B. If I did an indirect proof for this, I would end up saying squiggle, so not squiggle A and squiggle B as a provisional assumption. Try going anywhere with that. You will find that does not go places. So what do I need to do? Well, I said there's two pieces that we need. I need to get squiggle A. I don't have it. And I need to get squiggle B. So if I get these pieces separately, I can just and them in, and that's what we want to do. That's why I know I don't need to do an indirect proof of this, because that's not the mission. The mission is I need to get this, and I need to get this, and stick them together. Okay, so just like we've done some where we were building double arrows, we had to do a conditional proof for one part of it, and then a conditional proof for another part of it. In this case, we're going to do an indirect proof for this, and an indirect proof for this, and then and them in. So let's do it. Let's start with this one. If we want to get squiggle A, what are we going to do as an indirect proof? Let's provisionally assume it's contrary. That would be just plain old A as a provisional assumption with the mission of getting any contradiction. Let's do it. Now with this A in play, can we do an arrow out? Yep. Arrow out. Line 3 and line 5 gets us B. Arrow out. 3 and 5. Okay, cool. Now, can we do another arrow out? We can. Look, we can use this arrow out on B here and get an A, but we get A again. It's something that we already have. Now, what's the mission? The mission is to get any two contraries and stick them together. So what you want to do in these situations, too, is do a quick scan. What are some squiggles that I already have there? No. And there it is. I've got, in line 2, I've got squiggle A dot B. So cover that squiggle and see if you could build what's here. Could we just build just regular a dot b? Yup. So watch. If I say in line 7, a dot b, and in. Okay, 5 and 6. Look now, line 7 and line 2 are contraries. A dot b, line 2, squiggle a dot b. Those are contraries. Now it's bigger, but they're contraries. I can use them in an indirect proof. Let's check it out. Line 8, a dot b, and the exact same thing with a squiggle in front of it. What's that? And in. 7 and 2. Indirect proof complete. So I can zoom out and say, yeah, squiggle A, we're good. Indirect proof, 5 through 8. And that means I got half of what I need. I got half of this and in. So what I need to do, get the other half. Now we're after squiggle B. So what are we going to do? We're going to do a separate side quest where we can't use anything in here. This side quest was its own thing. None of this stuff carries over. Okay. Now 1 through 4 and line 9 are in play, but this stuff 5 through 8 does not carry over. Separate side quest. Line 10. What are we assuming? The opposite of our goal, or a goal right now, or the contrary of our goal. Our goal is squiggle B, so we're going to provisionally assume B. Provisional assumption. Quest, get any contradiction for this one. Okay, let's try this now. Can we do an arrow out? Yep. Line 4. What does that get us? A. Again, we already have A. We got it in line 5. Separate side quest. Arrow out. 4 and 10. Okay, do a quick scan. Can I do another arrow out metastolens? Now, again, look, like I said before, when you're trying to do an indirect proof, do a quick scan. Do I have any squiggles already around? And in line 2 again. Now remember, this one I can use as many times as I want. The stuff inside another side quest, again, that's off limits. I can't use it. Why? That's just how it works, logically. This stuff can't be reused. Anything in the main game can be used as much as you want. So look, we're going to do something similar to what we did in line 8 here. Look, first of all, I'm going to say A dot B. I already got that in line 7. Now it's a separate quest. So I'm going to say here, this A dot B is and in 11 and 10. Okay, because this is a separate mission. It's repetitive. It's kind of like if you ever play a game on, I don't like a roguelike. Like I'm thinking like a game like Dead Cells. You did it once, you got to go back and do it again. Okay, or you've played it before. Oh, you bought a game that you had on one system. Now you have it on another system. It doesn't mean that stuff carries over. You got to play it again. Okay, so we do line 13. We're going to take that and do exactly what we did before. A dot B, and the exact same thing. The squiggle in front of it, and this time it's and in 12 and 2. It would be a mistake to say 7 and 2 because this is a separate quest. Bam. We did it. We provisionally assumed the opposite, contrary of our goal. We got a contradiction. That means we can zoom out and say line 14. Yep. Squiggle B. Indirect proof. 10 through 13. Which means we got it. We got the two things we need. What do we need to do? And them in. That's it. Squiggle A dot squiggle B. And in. 9 and 14. We got those pieces we needed. Now this is kind of like looking under the hood to make it work. Same thing here. But we got it. Squiggle A dot squiggle B. Mission accomplished. From here, what I want to do is, now that we completed the problems in the book, there are some other ones, 16, 17, 18, 19, 20, pages 90 through 91. Those are challenges. I find them, they're doable, but they're so challenging that it ends up being more obnoxious than I think really helpful. So what I want us to do from here is I am going to do some problems from your upcoming quiz, namely quiz 5. Just like I've done on the previous quizzes. Show you a couple problems, we'll go over them together. Let's do it. Okay, here is the batch of sample problems for quiz 5. Alright, so these numbers won't necessarily correspond to what they actually are on the quiz. So 2 of the translations, 1 translation to a proof. It's a big one, but I'm doing it here to show you how to do it. And then also just a plain old proof where we don't have to translate. So we've got the first one, Vanessa is going to the party just in case. Madison goes, and if Gabrielle goes, then Alexis should be coming too. But if Alexis isn't going, then Gabrielle definitely won't go. Got that? We've also got, if it's a shape, then it's a circle exactly if it's round. Then we have this monstrosity from Game of Thrones. Winter is coming. If King Robert Baratheon is the rightful king of Westeros, then the Targaryens have no easy claim to the throne, if and only if all the Targaryens are dead. The Targaryens don't have an easy claim to the throne, but not all the Targaryens are dead. Daenerys Stormborn's being alive is a necessary condition for Robert Baratheon not to be the rightful king of Westeros. Jon Snow is sad. Therefore, King Robert Baratheon is not the rightful king of Westeros, just in case Daenerys Stormborn is alive. Moreover, Jon Snow is sad. Nevertheless, winter is coming. And then finally, we have the following proof, just this. E double arrow G, G double arrow F, solve for E double arrow F. So, again, when I break them down here, the way that it transfers over, the letters and stuff don't quite look right. But here, what I've got right now, what you see on the page, is exactly how these are going to appear on the quiz. You'll notice, for example, notice here the giant semicolon. That means, hey, parentheses or brackets are needed here. Okay, tinier semicolons. Look around and see. Is there multiple stuff around? Then it needs to be grouped together. All right, so that's why this stuff is this way. Same thing here with number 2. Semicolon, that means something like, hey, you should do something with this. Stuff needs to be grouped together. So this is what it's going to look like on the quiz. Let's get into these 4 problems. All right, let's take a look at the first one here from the quiz. So Vanessa is going to the party just in case. What does that mean? Oh, double arrow. Right, she's going to the party just in case. So I'm going to draw a double arrow right over that because that's what just in case means. Madison goes, comma, which means this is its own thing here. And if Gabrielle goes, that means there's an arrow here, then Alexis should be coming too. Comma means there's a break there. But if Alexis isn't going, so that's going to be a squiggle there, then that means there's the arrow right there. Then Gabrielle definitely won't, there's negation, go. So let's do it. So Vanessa is going to the party just in case Madison goes. Okay, that's its own separate thing. And, which means that and is here. That goes together. And if Gabrielle goes, then Alexis should be coming too. That's its own thing. But if, so here's an arrow. If Alexis isn't going, then Gabrielle won't go. Okay, this is looking great. Is it dyadic? Nope. It's triadic. Look, we got this and this and this. So 3 parts. But look, it's actually all connected by ands. So what we need to do is we need to do some grouping around this, but it doesn't matter what we do. So we can put brackets here and here. Is this dyadic? Yeah, we got a left and a right. That's fine. We could also just as easily put them here and here. And this is just as fine too, and just as correct because now we have a left and a right. Because since it's all ands, it doesn't matter where we put the grouping mechanisms. So this one says if it's a shape, and then it's got a semicolon here, which means that's a break. Stuff needs to be grouped. So is there multiple stuff on the left? No. Is there multiple stuff on the right? Yeah, 2 things. That means parentheses are going to be here definitely. That's what that semicolon means. If it's a shape, so there's an arrow in here, then so the arrow is right here. Then it's a circle exactly if is a double arrow. Circle exactly if it's round. So what does that mean? If it's a shape, that goes on the left side of the arrow, then grouping mechanism, then it's a circle exactly if it's round. That's it on this one. Let's take a look at the outrageously long next one where we have a translation into a proof. All right, let's take a look at this lengthy problem. Winter is coming. Okay? And so I'm actually going to go ahead. I know this is going to take a lot of space. So I'm going to go ahead and split this into two halves. I know I'm going to need that screen space. So line 1, winter is coming. And just that. That's assumption number 1. Assumption number 2, and I see that here. Winter is coming. Line 2, if. That means there's an arrow. If King Robert Baratheon is the rightful king of Westeros, and that semicolon there means there's a separation here. If there's multiple stuff here that goes together, and it does, that means there's an arrow. On the left side of the arrow is just Robert Baratheon is the rightful king of Westeros. More stuff. Then what? The Targaryens have no easy claim to the throne. Easy claim. If and only if, what does that mean? Double arrow. If and only if, all the Targaryens are dead. Assumption number 2. Okay, assumption number 3. The Targaryens don't, that's a negation there, have an easy claim to the throne, but, that means and, not all of the Targaryens are dead. So they don't have an easy claim to the throne, but they're not all dead. That not, there's a negation there too. That's assumption number 3. Assumption number 4. Daenerys Stormborn's being alive is a necessary condition. Necessary condition means it goes on the right side of an arrow. So her being alive goes on the right side of an arrow for what? Robert Baratheon to not be the rightful king. Robert Baratheon is not the rightful king. Assumption number 4. Jon Snow is sad. That's just J. Assumption number 5. Alright, let's take a look at the conclusion here of this. Robert Baratheon is not the rightful king of Westeros, just in case. Hey, that means double arrow. Daenerys Stormborn is alive, just in case. So double arrow that. Okay? Then there's a semicolon saying, hey, there's some more to be added to this. Moreover, and Jon Snow is sad. And then it says, nevertheless, in the original version, if you look at it the way it's going to be on the quiz, there's a giant semicolon here, which means all this stuff goes together. Nevertheless, which means and, winter is coming. Okay. So this is what we got in play. Let's solve from here. Do we have any arrows not in parentheses? Yep, we sure do. Left side matches? Nope. Okay. Do we have any double arrows not in parentheses? There is a double arrow. It's in parentheses. Do we need dots not in parentheses? Yes. That gets us these two things, 6 and 7. Squiggle C, squiggle D. And out line 3 for both. Let's put that together rightly. So here, can we do an arrow out? No. Double arrow out? No. And out? No. And in, double negation? Doesn't go anywhere. Is our goal an arrow? No, our goal is an and. So the last move of this problem is going to be an and in. Now take a look at this. See what we need to make. Do we have this stuff? No. Do we have a W? Yes. Alright, so that's good. We're 50% there. Let's zoom into this now. So for this, do we have squiggle R, double arrow S, and J? Do we have the J? Yeah. Do we have the squiggle R, double arrow S? No, we do not. Do we have the J though? Yeah. We don't have the squiggle R, double arrow S, but what would we need to make that? Okay, squiggle R, double arrow S. We need two things. We would need squiggle R, arrow S, and we would need also S, arrow, squiggle R. Do we have either one of those? Actually, yeah, we have squiggle R, arrow S in line 4. We don't have S, arrow, squiggle R though. So this is what we need to work on. So let's actually do that. Here's what we're going to do. We're going to say here this. We're going to go line 8. We're going to start a side quest. We're going to say, hey, let's provisionally assume S. And what we're going to want to get is squiggle R. Okay, let's do it. Does that get us anywhere? With this S in play, can we do anything? Arrow out? No. Motor stolen? No. Keep going down the list. No, 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 no. So what's our goal at the moment? Our goal at the moment is squiggle R. So what do we need to do? Start another side quest. That's an indirect proof. So we need to get squiggle R. So here's what we're going to do. In line 9, we're going to provisionally assume just plain old R, provisional assumption, and our goal is to get any contradiction. If we can do that, we can prove that squiggle R is a thing. Let's do it. Now with this R in play, can we do an arrow out? Yeah. Line 2 and line 9. Where does that get us in line 10? And here we're still in the subproof. We're in a side quest. In line 10, that gets us now this double arrow released from the parentheses. Squiggle C, arrow D. How so? Arrow out, 2 and 9. What should we do with this double arrow? Break it down. That gets us two things. Squiggle C, arrow D, and D arrow, squiggle C. Double arrow out, on line 10 for both. Now, we got two arrows here. These are fresh. Can we do an arrow out on either one of them? Yes. Look, we got this squiggle C, arrow D. We have this squiggle C over here. So what does that allow us to get in line 13? D. Arrow out. The arrow is in line 11. Its squiggle match was in line way back in line 6. And look now, do we have two opposites, two contraries? We do. D and squiggle D. So look, we put them together. Line 14, we say D and squiggle D. And in 13 and 7. This means what we started here in line 9, it keeps going to line 14. We can zoom out and we can say, hey, in line 15, the thing that we were trying to get, okay, remember, we were trying to get squiggle R. And our mission was we can get squiggle R is if we provisionally assume R and we get a contradiction. We did that, which means squiggle R is a thing. How so? Indirect proof, 9 through 14. Now, hey, the squiggle R was actually something we were trying to get way back in line 8 with a conditional proof, which means 8 to 15 allows us to zoom out and say in an arrow, hey, S arrow squiggle R. Arrow in 8 through 15. There it is. Now take a look. Now, remember what we're trying to build. We're trying to build this big thing here. Look, now we have the thing. We had the squiggle R arrow S since the beginning. Now we've got S arrow squiggle R. What can we do with that? Double arrow it in. Look, line 17. We get squiggle R, double arrow S. How so? Double arrow in. Two things. Line 4, line 16. And then what do we do with this? We want to add on, we want to adjoin it with J. So line 18. This thing, squiggle R, double arrow S, and J. And in. Okay, 17. Whether or not you can see it, I think my face is going to be blocking this here, but it's 17. Where was that J? Way back in line 5. And then finally, line 19, we can take this thing, squiggle R, double arrow S, and J. And we could say that and W. How so? And in, and since my face is probably blocking it, think about it, and in the thing we just got in line 18, and where was that W? Way back in line 1. The problem now is done. Final problem from quiz 5, it's just a proof. Let's see, let's go through the list. Arrow out, no. to Modus Tollens, no. Do we have double arrows? Yes. What should we do with both of these? Break them down. So that's what we're going to do. Let's break down the first one. We could do the second one first, but I'm going to go ahead and do this one. That gets us E arrow G and G arrow E. That's double arrow out on line 1 for both. Okay, we got fresh arrows. Can we do arrow out now? Nope. So let's go ahead and break down the second one. 5, line 6, we get G arrow F and F arrow G. Double arrow out on line 2 for both. Okay. Can we do some arrow outs? No. Modus Tollens? No. Double arrow outs. We can do some double arrow ins, but it only gets us what we already have. And outs, no. And in, no. Duplication, no. But look at our goal. Our goal is a double arrow, which means we're probably going to do, in fact, we're definitely going to do a double arrow in. So what two things do we need to make that? We need E arrow F, and we need F arrow E. Get these two things, we're good. And we can just double arrow them in. So let's do it. Let's start with this one. Let's provisionally assume the left here and get the right. So line 7. Let's provisionally assume E. And let's seek F. Okay, with E in play, can we do an arrow out? Yeah. We get G. Arrow out, 3 and 7. With the G in play, now look, we have two options. We can get E again. Well, let's not do that. Let's get F. That's the thing we're after. So line 9, we get F. Arrow out, 5 and 8. Side quest complete. We can zoom out and say line 10, hey, we get E arrow F. That's the thing. Arrow in, 7 through 9. This one checks out. So we're halfway to getting this E double arrow F. Let's do the other one. For this other one, we want to provisionally assume F and get E. Let's do it. So we zoom in, line 11. We're going to provisionally assume F with the goal of getting E. Okay, so remember, this stuff is off limits. Like we might, like, hey, we already got F. No, it's off limits. It was on its own separate side quest. Let's do F now. Can we do an arrow out? Yep, we get G. Arrow out, 6 and 11. With G, we can get F again. We don't need to do that. Let's get E. And so arrow out, we're able to get through 4 and 12, we're able to get E. Okay, there it is. So in line 14, we can say, hey, F arrow E is a thing. That's fine. We can stick an arrow in there. Where did that process start? Line 11. Where do we finish it? Line 13. And in line 15, look, this thing and this thing, we can just double arrow it in and get E double arrow F. Double arrow in 10 and 14. And this is indicative of the kinds of problems you'll have on quiz 5. This so concludes wave 1.